Hello and welcome to this masterclass on hair and fur in Houdini 16. My name is Kai Stevkinski. I'm a Senior Technical Director for Side Effects Software. Let's start off with an overview of the things we'll cover. First off, we have a new set of object-level tools that replace the fur object that came before it. They represent a far more flexible and modular approach to grooming. Then we'll look at actual grooming techniques and we'll see how you can use the same set of SOP tools to manipulate both guide curves as well as the full generated hair, both in the viewport and at render time. Then we'll take a step beyond the actual hair-related tools that we ship, and we'll see how we can use the power of Houdini SOPs in general to manipulate our grooms as well as the generated hair. And finally, we'll see how we can use a new set of low-level SOP tools that we ship to build hair effects from scratch without using the object-level infrastructure that we provide. And with that, we'll also look at how you write grooms to disk and how file I/O works in general. To get an overview of the entire workflow, let's look at the sample project. It's just our rubber toy geometry with an FEM simulation run on it. And it gives us an opportunity to look at the object level tools that we have, a brief look at some of the SOP tools, as well as simulation and hair generation. So let's jump over to Houdini. And the scene I've got here is relatively straightforward. I've just got my lighting and cameras here, some simulation bits, and then this is the static geometry. And the simulated geometry, let's look at that from the camera. So this is the FEM simulation in Houdini. And then these are the fur operators. So first off, we have guide groom. And this one has a very simple purpose. Basically, it generates the guide curves according to the density parameters and so on that you set here. And then it has an editable network inside where you do the actual manipulation of these guide curves. And these curves are then later used by simulation and hair generation. I can bypass the editable network inside where I have some customizations already set up. And this just gives you the result of just these parameters here. So density, scatter seed, and so on. I will go into more detail about these later. Let's turn that back off and jump inside. So this is the basic structure of the editable network inside here. And one big difference to what we had before is everything is happening in one network. So there's no longer any separation between manipulating guide curve geometry or painting skin attributes. It's all flowing through this graph. So we've got all the bits that make up the groom coming in here. Most important are the guide curves and the skin, and then the VDB of the skin is used by some operations to compute collisions and avoid penetration with the skin geometry. And then these operators all have 3 inputs at least and 3 outputs. And that lets us flow all this data through the operators. So the skin coming into the second input here is also coming out of the second output. And the nice thing about that is you get a very clean graph. So for example, if the operator down here required some skin attribute that's coming in from the inputs here, it has access to that through this output. So you no longer need to reference skin geometry from up here and end up with a messy network. And another advantage is that all of these operators can occur in any order, so you don't have all the skin painting first and then all your guide manipulation. You have complete control over the order of operations, and it's all very flexible. Let's jump back up. Next up we have guide deform. I'll unhide the simulated geometry again. And guide deform is very simple. It simply moves the guides with the animated mesh. There's no simulation at this point. They just keep the groom that you set up. And the way it gets that groom is by this reference to a groom object. So all of these we call groom objects. And this is a reference to the actual object, not a specific geometry like the curves or skin inside. The operator itself knows how to extract that information. And then we add the animated skin. And that's necessary because the guide groom doesn't actually know about the skin. It doesn't have any reference to that. We just have the static geometry here. And then we also have caching controls where you can write out a sequence. It's often not necessarily because this is quite fast to do in the first place. But you can do it there. And then we have guide simulate. So this one, again, takes a reference to a groom object. In this case, it's the guide deform. So it uses that as the base to run its simulation on the wires. Play that back. This is cached to disk. You can see that happening here. I've got some turbulent wind running on that as well. You can use this to actually run a simulation without a Houdini effects license. So in Houdini Core, you can still use these built-in material parameters, forces. So we've got wind with turbulence and drag, and some new clumping controls, as well as collisions and caching, of course. And the final piece of the puzzle is the hair generation. So this operator, again, takes a groom object, takes the simulated guides here, also takes a reference to a skin VDB. It can generate that itself as well, but here you can write it to disk and reference it. And then similar to the guide groom, we've got controls over density. So this time that's responsible for actually growing hair. Let's bypass the editable network inside for now. This just gives you the basic generated hair. And then here I can change my density, relaxation, and so on. And then I've got some extra controls over how the guide curves influence this hair. Let's have a quick look at what those parameters do. So the influence radius controls how large of an area each guide has influence over. If I reduce that, you actually see that some hairs will disappear. Let's go up in density again to make that a bit more visible. So you want that to be at least high enough to cover the character, and then maybe a bit higher just to smooth out the effect of individual guides. So you basically want each hair to find at least a couple of guides, or 3 or 5. And then a more subtle control over the interpolation between guides is this influence decay. So the higher that is, the more the influence fades with distance. So it effectively makes the interpolation more localized. You can see that here. Where's a good spot? Maybe here. So if I go even higher, you can see these hairs follow that one guide much more closely now. And if I reduce that, the effect becomes smoothed out to the point where you lose a bit of the fidelity of the simulation. So somewhere in between, that seems to work quite well. Now, actually, it looks a bit lumpy here still, so probably I need a bit higher radius and maybe go down a bit on the influence. Now, you may find that some of these areas work well, and then others, if they're too smoothed out, like here, then you can actually go in and override some of these attributes. But to look at that in detail, let's get rid of this and see how we can set up something like this from scratch. I'll get rid of my existing fur nodes, unhide the simulated character, and then to start with this, I'll switch to the grooming desktop, because that just gives me quick access to all the shelf tools I need. And then it also switches me to the hair specific radial menu, which is this one. So that's very useful to just navigate between the various objects that make up a groom. And then you get quick access to procedural guide tools here and interactive brushes over here. But let's start with the add fur shelf tool. So that asks me to select a static mesh and then an animated mesh. The animated mesh is optional at this point, but if you do pick it, then you get a guide deform like we've seen before. And the hair will show up with the animated character. So you can see the hair is generated here, as well as the guide deform node showing up there. Let's just verify this all works. So that's everything moving with the simulation. But for now, I actually want to jump to the guide groom. So let's unhide that. And I also want to display the generated hair in the static position. So one way of doing that is just disable use animation here, and that'll ignore the animation coming from guide deform. Another way, it's sometimes more efficient, just reference the guide groom directly in the hair generate. So I can drag that in here. And then regardless of use animation, it's static, and there are no time dependencies or anything, and you skip that computation that guide deform is doing, so it can be quicker. And now one thing I want to do is paint some areas where I don't want any hair. I could have done that as well by selecting polygons up front when I ran the add fur tool, but for something like this where I want fur on most of the character, I actually prefer to just scatter it all over and then just cull some areas. So let's increase density a little bit overall. And then I don't want any hair in the eyes. So one way of doing that is you can paint density. You can use this override menu here. Anytime you see this, it means you can override the value of these parameters with skin attribute that you can paint directly from the parameter interface here, or a texture. Now, texture painting is not supported in the viewport yet, but you can bring in an external texture here. We'll use a skin attribute for now. But actually, instead of painting density, I'll paint length here. And the advantage of that is that all the hairs around the area that I paint stay in place, and the density around the fringes doesn't reduce. So let's use that instead. So the attribute for painting is called length scale. By default, that's okay for me. And then when I click that button, I actually jump into the skin geometry. And I get these two nodes added. So attrib create to create the attribute in the first place defaults to 1 here because it's a multiplier against my length value. So by default, there's no change. And then the length, the paint SOP. And with that, I'm ready to paint actually. And I'll just paint the background value, the black here, which should make all these guides just disappear and shorten around the edges. And one thing I like to do for this specific task is just reduce the soft edge of the brush. And that just makes it a bit easier to paint exact 0 values to make sure that the guides are actually culled. So when you paint exact 0, you don't get any of the roots remaining there. I can see the points, it's just the points of the mesh here, but there shouldn't be any points of the guides. Oh, one thing I should mention here with this specific character, when we look at it here, I'll just go inside. You can see the legs are separate objects that just intersect the body. And we get some guides grown inside here. One quick way to fix it in Houdini 16 is just with a Boolean. So Boolean set to union actually creates a union of all the separate meshes in the geometry. And it's a very quick way of just very cleanly resolving that. Now, it doesn't give you clean quad geometry or anything, but it's very exact. Now, on top of this basic culling, I also want some length variation across the body. And to do that, I could paint the same mask, but let's just look at a different way of doing it. And I'll use guide tools set length. So that's one of the procedural tools that we have. It uses the guide process node with the operation set to set length. And one way I can work with this is just set an absolute value. So that's the default here. And that just completely ignores the length of the incoming guide and just rescales the curves to this specific length. I can also multiply if I want a relative adjustment. So by default, 1 doesn't have any effect, and then I can increase it and multiply whatever's coming in. So that'll preserve length differences that you already have in the input. Let's just set like a high uniform value here, just to increase it. And then I've got these masks up here to control where that effect occurs. So that's one way I can vary this. So for example, skin mask. Let's just call that length mask. Mask is a bit too generic. And then we have the same paint button that we have at the object level, but in this case, because we have all the data here in one place, we have the skin coming in here. That can just add these operators right there. So by default, it's masking everything if there's nothing happening. What if I paint value of 1 here? We get that operation occurring now in those places. Let's just quickly paint all the legs. I just want some longer hairs in those areas so we get something more interesting for the simulation. I won't go into too much detail with this one just yet. I think here I accidentally painted some areas when I culled, but let's ignore it for now. Now, another thing I want to do is just give the groom some initial direction. So one way to do that is with this initialize. And there are various tools to create the initial hairs here. I just want this guide, initialize guides. That gives me basically something where the hair just roughly flows around the character. It's just, we're simulating like a static wind with just a uniform direction. And it has this tangential to skin parameter, where you just get the hairs flowing around the curvature of the character a little bit. That's a nice quick way of setting up something like this. You're always going to want to do something on top of it, but it's just a quick start. And then to get some more control over that, I can use a lift operator. It's actually just a guide process again set to lift. Then I can control how much I want the guides to point away from the skin, and it also has this follow skin contour, similar, where you can make hairs not just stick out straight, but follow the curvature of the character. So when I go lower, you'll see that nicely flattening against the character. Now the guide deform up here picks up those changes right away. So you can see the same groom there, it just preserves that as the character is moving. And the hair generate should do the same thing. Except I have to plug in that guide deform again. Make sure use animation is toggled on. And actually, to see that a bit better, let's jump over to the hair shader. Make that a bit brighter. I'll just make that brighter and more saturated. And then jump back to the hair object and increase the thickness here a little bit. And I can hide the guide deform. Alright, so that's all working. So it's very basic at this point, but let's just try to get a render out of this. So one thing to note is that all this hair generation happens in SOPs. So this object level hair generate node, it uses SOPs to generate the hair based off the guides. And when it's rendered through Mantra, Mantra cooks that SOP network. And this is also true when you apply custom operations inside the editable network here. So I can jump inside this and actually use the same tools that I used before in the guide groom to do things like length variations and clumping. For example, guide tools, set length. Since I had the hair gen object selected and it's current in the parameter editor, set length will now be applied in there. So same set of tools. I've got the same sort of inputs here. It's just that it's in this case it's already animated. It's following the guide deform. And when I do something like set the length, multiply, I can randomize per hair. So this is no longer working at the guide level. It's actually manipulating individual hairs. So you can see these variations happening there at the hair level. And the same with something like clumping. So I've got this clump operator that's actually using the hair clump SOP. So this is all applied at the hair gen level. And I'll, just to make it look a bit nicer, let's go up in quality a little bit. More hairs. 20,000 density. And then we can go down in thickness a little bit. So you can see that working through the simulation as well. And another thing you might want to do at this stage is just add some frizz. So frizz tool, reduce the amplitude. And this is a good one where you can use the curve mask instead. So curve mask will give you control over where along the curve the effect happens. So by default, we just have this linear ramp here, which increases from root to tip. So you see, when I disable that again, you can see more of an effect at the root. When I enable it, there's less at the root, but the tip stays largely untouched. Then you can manipulate the ramp directly if you want to control the effect of that. But you also get these controls here for doing that a bit more quickly. You can set the fall off. And you can also set this effect position where you can control where most of the effect occurs. So in this case, it's now the middle of the curve. With the fall off, you can get nice control over the gradient. And you can also just get it at the root, but not at the tip. And then, of course, that works together with the other masking options. So something like the noise mask here, you can vary that for areas of the character. I'll just increase my gain here. That's basically like a contrast on the noise, so you can see that very clearly. Lower frequency, so you can see areas where there's lots of frizz and then where there's a bit less lowering the gain again. Makes it a bit more subtle. So all these things work together, and I could paint a skin mask on top of this as well. But let's just leave it like this for now, I think. Or maybe I'll just add a bit more, another level of clumping. So one thing with this hair clump operator, just increase the iterations here, and it then splits the existing clumps into more with control over how that happens. So goal feedback will basically make the subsequent iterations stick more to the previous level. So when I increase that, you'll see more clearly the first level of clumps and how the next clumps follow those. And tightness reduction just reduces tightness with each subsequent operation. So when I reduce that, you'll see the subsequent clumps being more defined. But we'll look at that in more detail in a more realistic example. Let's just leave it at this for now. Jump back up, and I'll add simulation into the mix. So to do that, you usually want to do that on the deformed guides for something like this. You can also simulate the guide groom, and the modular structure of these tools allows you to do that. So when I select the guide groom and click the animate shelf tool up here, it'll simulate this. It'll insert itself in the chain between groom and guide deform, and it can actually be useful to just work on the static groom using physical simulation. You just drop the hairs a little bit and then keep grooming on that. But in this case, I'll just do the standard like shot workflow of just simulating the deformed guides. So with the guide deform selected, simulate. So we've got these blue guides now telling me that it's the guide deform. Let's hide hair gen. And the wire solver that we use in here does tend to be a bit fiddly. It does take some tweaking. I know that for this simulation it works a lot better if I just reduce the spatial scale. There are some other things I could adjust, but this should work okay. I'll just simulate that and speed it up for you. All right, so that's simulated for a few frames now. Let's play that back. So you can see the wires swinging with the legs there nicely. Let's see. You can see it very clearly here. Well, let's see what that does to the generated hair as well. And they seem to follow nicely there. Now, since this cooks at render time and the procedural that actually generates the hair needs access to the input information, so it needs access to whatever groom object you have plugged in here, you need to render that groom object as well. So in this case, I need to render guide simulate. It's not going to work when I just hide that. Let's just verify that it works here. But all these objects are set up to not render anything visibly. They just need to be there for the procedural to be able to access that geometry. So right now Mantra is generating that hair based off those guides. And we get the clumping and everything happening. And you can kind of see the simulation, like the hair is lagging behind there. Probably have a bit too much thickness and everything, but I'm not going to dial this in with too much more detail. To look at more of that, let's jump to a more realistic example with an actual character and a more carefully designed groom. So with this example, let's first look at the overall structure of the scene. You'll see from the network editor, and just by selecting things at the object level here, that the groom is made up of distinctive parts. And the main purpose of that is just to help with setting up each part's properties. So for example, something like the eyebrows, by splitting this off into a separate groom object, I'm able to set global properties for things like frizz and clumping. Whereas if I was to combine this with other parts of the groom, I'd have to paint masks for all these things. And the same is true for something like the beard and the mustache. Now, an important part of this is that the guide groom objects here, each of them references a specific null within the skin geometry. It's all the same geometry, but they're all referencing a different branch. You'll see that here. If I click through a few of them, they all have a different reference up here. And there are two purposes of that. One is there are some attributes here that I just create in preparation for the groom, and they're usually only necessary for that part that I'm working on. So I can avoid multiplying these and accumulating these, and then propagating these through all the parts of the groom where they're only needed in one part. And then the other aspect is when I change something in one of the branches, it only causes a recook on that part of the groom as well. So if I had them all in one, imagine all of these in one chain, and you change one thing at the top, you cause everything down there to cook, and then also every part of the groom to recook. So all the hair would regenerate, and all the guide processes would recook. So I can avoid some of that. So for example, bypassing one of these will only pause a short time to recook the eyebrows. Now let's take a look at how some of these parts of the groom are actually constructed. You'll see that in a complex groom like this, the radial menus are still very useful. I can still jump into guides and jump between the parts of a specific groom here because the tools are able to figure that out based on the reference paths. So I can jump between guide, groom, and hair, and jump into guides, jump into hair. But let's jump to the guides now and hide the hair. And you'll see this one is made up of an interesting combination of tools. We actually have the comb node here, which we've had for quite some time, but it's still just as useful and maybe more useful now with the new set of procedural tools. So all this does is manipulate a vector attribute on the skin in the viewport. So you can go in here and brush the direction of that attribute. Let's change the opacity just to make it very visible. And this is then picked up by this guide process node here, which I just destroyed. But it's using that fur direction to override the direction that it sets per guide. And it actually has this button here, which is very similar to the paint button you saw before. But in this case, it would create that comb node. Let's actually look at how that would work from scratch. So let's get rid of this. And in this case, they go a bit crazy because I think we have a set lift operation here, and that doesn't quite know what to do when the guides are facing straight out in the normal direction. We'll fix that here with the comb node, so just create that. Let's actually make our visualization a bit better here. Let's just scale up those vectors. And then as I paint that, you'll see the guides reacting. I think we can hide our visualizer now. So this is an interesting combination of tools because it remains fully live and procedural, unlike the curve brushing tools that you have up here on the shelf. It doesn't require any recaching. So we just set up an attribute and then we remain fully procedural. So something like the blend and these sliders here, they will work to then modulate the effect that you paint, the direction that you paint. And you can, of course, keep working after that. So we have a set length operation here and then a lift, which looking from the top again, you'll see the nice effect of the follow skin contour. So just setting that to 0 makes the hairs stick out more straight. And then 1 makes it follow the contour. And you'll see that more when I lower the lift value. But let's leave them sticking out a bit. And then of course it's very quick to go in and adjust these things. So I could have multiple things combined in one guide process here. So I could paint an overall mask for these just by using the skin mask. But I can also go in and adjust individual things. So one thing you might want to adjust is the lift here. Let's say I want to vary that a bit. So I'll use a skin attribute, lift, and just start painting. And that just adds a paint node to the chain here. I'll disable symmetry. So let's just lift some hairs a bit more. So since this is a multiplier, I want to go above 2 now. And then you'll see the effect of that. Maybe a bit less opacity here. So maybe these ones want to stick out a bit more. So it's very quick and easy to vary the effect there. And then next we have a frizz. And you'll see we also have a frizz operation at the hair level. So if I jump into hair, we have the same thing again. And the purpose of these is, well, the one in the guide groom, if I disable all of these, so we just see the effect of the guides on the cleanly generated hair. You see some of that coming through here. Let's also display the guides. So you see some of that coming through here, and it's a more coherent effect, so it's smoothly interpolated. And then the frizz in here gives you more randomization between individual hairs. But let's disable that for now. Let's look at how we can control the interpolation at the hair gen level here. So back at the object level, again, you can use the influence radius here. Let's just try to halve that from the current value. And you'll see that the effect, again, is more local, and it follows the individual guides a bit more closely. Just halve that again. So you get more and more of that. But again, I like to usually make that fairly smooth and then dial in the specific look with the influence decay. So just raising that, I'll double that now. Again, gives you a more localized effect. Double that again. And lowering it gives you smoother interpolation. And that just makes sure that every hair, you set the radius high enough so that every hair finds a few guides at least. So then in the simulation, it tends to look better that way. But you still get that detailed look where you don't lose any of the fidelity of the simulation and the setup of the guide curves. Let's jump back into hair gen. Now let's just look at the effect of each of these. So again, the frizz just adds some additional randomization. And then we have clumping with a very small clump size. Very simple here. Just set the global clump size and a stray rate. Of course, you could paint the clump size as well to vary things. Let's maybe try that. So skin attribute, clump size. And again, we want to go above 2 here to increase the clump size. So you see it's very easy to create variations there and lots of detail and create something realistic quite quickly just by stacking these individual operations. And then just another frizz. Each operation becomes progressively more subtle, but they just add up to something fairly realistic in the end. Now let's make some modifications to the beard just to look at different techniques that we can use there. So I'll jump into the guides, hide the hair again. And I already have this operator here, which is just empty at the moment. What I want to do is add a few operations here to essentially create a style for the beard. So I'll just make that a bit longer. And then set direction. Point that down a bit more. And then I'll use the blend to just reduce the effect a little bit. And add some frizz to the guides. So frizz. Something like that. And now, because I have all these in one operator now, I can use the skin mask to paint an overall mask for all of these. So let's try that. So by default, it's all at 1. So by default, the masks are always set to 0. In this case, I think I want 1 everywhere. So I'll just set the opacity to 1 and apply all. And then I'll just paint some areas where I don't want the style to be applied. So I'll reduce my opacity again, and I can go in and paint these areas, and you can see the guides reacting right away. And you can see that we're both reducing the length as well as the frizz. So it's very quick to do something like this. And then, of course, I can work in more detail. So this is my overall mask. And I can now still adjust all these settings, and you can see that the effect only occurs where my mask is still painted to a value of 1. And now, for more subtle effects and variations, again, you can combine this with overriding individual parameters. So if I wanted to do something like create more high-frequency frizz in some areas, I can do that. Let's just check how many segments we have on the hair here. Maybe I want to increase that a little bit. I'll use something like 16 just so I can represent my, just so my curves are able to represent a higher frequency frizz value. And I'll use a skin attribute here, and let's just paint that. So again, I'll multiply by 2. And you can see that happening there, so the frizz becomes more frizzy. Now another thing I can use here, let's just get rid of that again. You've probably seen this guide attribute option here, so I can use that as well. There's no paint button there because it relies on attributes on the guides. So very useful for randomizing with some more control, or just driving these operations with anything you want. For example, you could just create a wrangle node here. Let's remember the attribute frizz frequency scale. I'll copy that. So if I just paste that in here and set it to 2, you'll see the frequency double for everything. But then, of course, you can randomize that. So I could randomize based on the primitive number, for example, or then fit the 0 to 1 random number that I get out of that to a different range. So, for example, variation between 0.5 and 2. Very easy to do. Or just as another quick example, you can use the relative bounding box. So that gives me a normalized value, vector value across the whole bounding box of the guide. So if I use the axis of that, you'll see the frizz value increasing from left to right. So here there's hardly any frizz, and here there's a bit more. So all this stuff is very easy to set up. You don't have to go to the extreme of the wrangle node either. You can use something like the attrib randomize SOP and all kinds of SOPs that are there. So for example, let's just set that up as well. Primitives, attrib name, frizz frequency scale. And you can see that reacting there. And I can do something like a normal distribution, set the middle value at 1, and then just scale the randomization around that. So you get full control using any of these SOPs that are already there, or anything that you want to make yourself. But you don't have to then go to the lengths of reproducing all this math or code that is happening here to apply the frizz. You can just create the attributes that you need and then override them and apply them using these nodes. Now let's try another thing. Let's also add some clumping to this beard. So I'll use the radial clumping. The defaults don't work very well at the scale of this character. I'll just reduce the clump size here. A bit bigger. I think I want a bit less frizz. It makes the clumping go a bit crazy. There's still quite a bit of space between these clumps. Sometimes that happens due to the hair width scale here, because the clumping takes into account the thickness of individual hairs based off their p-scale attribute. In this case, we don't have one on here on the guides, so it creates a default value. In this case, it doesn't work that well, so we can reduce that here, and then you'll see the clumps getting closer to one another. I'll leave a little bit because it just makes it look a bit more natural. And then something I like to do before clumping as well is vary the length a bit. So I'll create some length randomization. You see that they mostly end, the hairs of a clump mostly end at the same point, and it just looks more natural when you have some variation in there. So I'll just go back to my set length here and change that to a randomize. I'll start with the values that I was using before, but just randomize that a bit so I have some shorter hairs in there as well. Now with this one, let's go in and use a skin mask as well. I just want the clumping to happen in a few areas, just something a bit more subtle. Again, no symmetry. Let's just do a bit here. All right, and then let's have a look at what this looks like in the hair now. So unhide the hair, and you'll see. So I did my clumping at the guide level, but it propagates nicely to the hair, to the generated hair. And again, we can control that at the hair gen level with this clump crossover. So setting that to 0 makes it follow the guides very closely. And then 1, randomizes it a bit. You can still see some of the effect of the guides just because they are close together in space. Oh, I've got the wrong one here. Select in the viewport. Unhide the guides. So you can see some of the effect there, but it's not very clear. So you usually want something in between, or just go very close and then add additional variation in the hair gen. So let's try that here. So again, something very useful is applying those operations at both levels. So I'll use the guide-based clumping, which is also respected in the simulation, by the way. So when you simulate this, they will stick together. But I'll do an additional level of clumping in here, just to break up the clumps within the clumps. This gold feedback, again, makes subsequent clump iterations follow the previous ones more closely, so you get more of the effect from the previous one. And then I'll just add some frizz on top again. You'll see that a lot of times you're using the same tools over and over. But you just combine them to create the specific effect that you want. Now the final part I want to look at with this character is the hair. Let's jump into the guides for that as well. And you'll see it uses a combination of procedural and brushing tools. So the procedural tools set up something very rough, maybe a bit too long, to then brush into shape. So I think this was actually an earlier version of what we tried to achieve. Then cut it down again with just the procedural tools. So that's just a length multiplier with some randomization. If I change the blend value here, you can see the effect of that. The hair gen takes a while to recook in this case because of multiple levels of clumping. I'll hide the hair for now. So there's one to set the overall length, and then another one to do randomization on top of that. Then there's nothing stopping you from going in again and using the brushing tools. So that's what's happening here. And the great thing with this is you still retain some level of proceduralism. So at the moment, this would be locked. Like if I make some modifications upstream, they're not going to propagate automatically. I'll just show you this. But then you have the recache button here, which fixes that. So for example, if I add some frizz, let's display this one for now, so we can see the result live. So just some randomization. Then the guide groom doesn't pick that up, but you can recache strokes here, and you retain all the groom that you did, but you just incorporate that frizz as well. Let's just maybe continue with some operations here. Like let's use the cut hair tool. So you can do things with these, obviously, that are very difficult to achieve with just procedural tools. I mean, I could do something like a Boolean or clipping on the hairs, but it's often just more convenient to just go in with the brush tools. And then again, I can still adjust things up here. Let's get rid of the frizz again. Recache. And everything propagates. So all these careful grooming operations that you did, they are preserved. Of course, it has its limits. Like if I change the length drastically here, like let's just make it way shorter. Then of course the brushes that I made in a certain position here are not going to have any effect anymore, that cutting that I did there. But it's very useful nonetheless. Let's jump over to hair generate for this. So here you'll see, again, very straightforward. Some frizz up front, and then the hair clumping. Let's just see the effect of that. So here you have the first one again, and splitting that, and splitting it again. And there's just a skin attribute to paint where that effect occurs. I think this one was actually set up in the skin geometry, so I'll jump to that. So there are just some wrangle attributes here that set it based on ramps. But you could just as well paint it. It's just regular Houdini attributes, so you can create them any way you want. So again, for a very distinctive style, it's fairly easy to set something like this up with the same tools as well. But sometimes it helps to just use that combination of procedural tools to set things up initially, then maybe jump over to guide brushing tools, And the structure of the tools makes it very easy to do that. So next, let's go a bit beyond the built-in fur tools, and let's look at how we can use the general power of Houdini SOPs combined with fur. I'm using this font back here. So it's basically just a font geometry looking like this, that I'm driving some fur attributes here, and later we'll do some other more custom effects with that. And basically what's happening here is I'm creating an attribute on the primitives that gives me the distance to that geometry for each curve. And then that's what's driving the scale factor here. Let's look at it in a bit more detail. So this is just my geometry. There are no special attributes on it. And then the ray SOP set to minimum distance and with transform points off. So the points just stay in place. If I transform the points, they would just all jump onto the font there. I'm turning on point intersection distance, and that gives me this attribute per point. So some of them will be very close, sitting right on the font geometry, and some will be further away. I'm promoting that to the primitives with a minimum promotion method. So that gives me, for each curve, it gives me the shortest possible distance to that font geometry. And that goes into this attribute VOP and is remapped using a ramp. Let's look at the effect of that on the set length, on the guide processes set length here. So first of all, I can control the range of the effect. So a minimum value here. When I set that to 0, it breaks a little bit because some of the points are not quite sitting on the surface. And then an outer range. And I've got this ramp where I can control the fall off. So this will make the fall off a bit steeper. Most of the hairs are still long here. More linear fall off or something like this. And then in addition, I've just got this random offset. So this just offsets the position along the ramp randomly to make it a bit more random. When I set that to 0, you can see the effect becomes quite smooth, especially when I have a greater radius. And this just randomizes it a bit more. Now let's jump inside here. I'll just give you a quick look. Let's ignore these parts for now. Basically what's happening is it's taking the distance attribute, piping that into a fit, and then using these distance parameters that you saw at the top as inputs, as my range, and then just mapping that to 0 to 1. And over here, this just adds my random value. That's the green box here. And basically just feeds into a ramp and exports as scale factor. I'm also exporting just this attribute I call font mask, which just gives me 1 where there's the font and 0 where there isn't. And then this randomization. Now one detail I want to point out here, I'm doing the randomization based on the ID attribute that we get on the primitives. So if I jump up, just middle click on the hairs, you've got ID here. And that's quite an important one. Basically, you don't want to do it based on the primitive number. Sorry, that broke something. Because there are some things that can mess with that primitive number. For example, if I use my limit to bounding box on the hair generate here to speed up the computation, you'll see that with the method I'm using now, the random values stay the same. I get the same length that I get without it. And the same with pruning. So when I activate pruning, of course, some of the hairs disappear as you want, but the ones that remain stay at the same length. And you'll see if I jump inside here, let's just set a quick mark on that, Control 3 and Control 1 here. So if I connect the primitive number instead, the result changes right away, and also it changes when I activate limit to bounding box. And when I prune, the hairs disappear, but also the remaining hairs change length. So let's set that back. It's always important to use that one. And of course, I can use that now. I can use that mask, but then I can go back to the guide process and just adjust things there. So I'm using the blend value here to set to leave some remaining distance, so the attribute just scales to a complete 0 in some areas. I'll just set that to like 0.8 to just shorten the hairs there. And of course you can use this to drive anything you want in the guide process and other SOPs. Then another thing I'm doing here, you can use the same sort of base setup to create some clumping around the font instead. So that's not just driving attribute, it's creating just a quite different effect. Let's see what that looks like with the whole font. Just bypass the internals for now so I can quickly adjust the bounding box. Just cooks a bit quicker that way. Now this one, the setup here is quite simple as well. We take the same font geometry and I just copy some lines onto that. Notice that the font geometry has some detail though. Can we see that? So there's some mesh detail. I just did a remesh on the font. Just quickly show that here. It's the remesh. So copying lines onto the points will create quite a few lines. And then I'm back to regular guide process nodes. So here just set the direction to point down a little. So it's just -1 in Y and then a blend value to control how much they point down. Then some random bending. So that's first of all the uniform bending here. And then on top of that, this random bend value. Just break things up a bit, and then just some additional frizz. And then in the hair clump, the only difference to what you saw before is instead of using the built-in sort of clumping where it clumps all over and relies on the skin mask and everything to paint out areas, we plug in, we use the fourth input to plug in custom curves here. And you don't really need any special attributes on these. We have a few, but none are required. It just uses whatever you give it. The one thing you have to make sure is that things are consistent with animation. So if these inputs come in animated, so sometimes you have to do some extra work there to make sure that everything stays static. But in general, you can use any number of SOPs you want to create these custom effects. Where it gets a bit tricky is with referencing external geometry. So usually I'd recommend writing things to disk that you need in here and referencing it right in here. If you do use external geometry, like if I had a separate object here, you have to make sure that you render that as well and just set it to invisible. So the best way to do that is just add in edit rendering properties, just add VM renderable. Set that to 0, or just turn that off, in other words, and then make sure this renders. And the same with, since all this is generated at render time by Mentra, make sure that it has access to the guide groom networks at render time as well, because there's a reference to those and it requires those at render time. What I do here is just put all the grooms into force object. So since they're named consistently, I can just use this pattern here. That's the easiest way to do it. You can also just display them, of course, but then they might be in the way of your grooming sometimes when you just concentrate on hair. Let's actually see what that looks like rendered now. You'll notice the bounding box that I've set here is ignored at render time, so you can just render it and still get the full hair. Let's also try another variation of this. I'll just leave my clumping on here, but additionally, I want to create some color variations here based on that same effect. So I'll create an attribute VOP again. Let's jump in here. We don't need the globals. And I'll just bind to the font mask attribute that I've created before. Remember, that's just a mask telling me where we have the font. So I created that here. It's just the complement So basically 1 minus the distance mask coming out of here. That's my font mask. And then I want to use that to mix two colors. I'll use a color mix for that. That goes into the bias, and then for now I'll just set that to black and white. So where there's font, it'll be black. And when we export that to, let's see, bind export that to a color named CD, so just the standard Houdini color attribute name. Oh, and this should be a primitive running on primitives. I could have just created a primitive op here. So that works, and it's going to propagate through to the render as well. But let's actually get some more control here, and we'll reset the shader values, the shader color values, to white, so we have just full control over the color using that attribute. So let's go white here, desaturated. Oh, and I think we're re-rendering still. Let's cancel that. And then this goes white. And now we can just directly set the colors here. Let's try to dial in something similar to what we had for the hair color. That kind of works. And then we'll use Houdini orange here. Side effects orange. Not too accurate. So very quick and easy to do that kind of stuff as well. Of course, there's a bit of weight to a bit of a memory footprint to creating these extra attributes. So it doesn't always make sense to do it this way. You might want to bake some of this to textures, but if you're not too concerned with it, and with a character like this, it doesn't matter all that much, I think. You can do it. One trick you can use here is just cast. Well, first of all, you want to clean up some of the attributes possibly, but you can cast some attributes like the color to 16-bit values. That saves a bit of memory as well. You can verify that here. That shows up as a little 16 to its side now, so it'll be half the memory, and that's fine for these values that are in the 0 to 1 range. You don't need more than that. So this will just show up in the render when you have tint with point color enabled. So remember that one. Now in this final segment, I want to look at some of the lower level SOP tools that we provide. So we'll forget a bit about the object level fur specific infrastructure that we have, and we'll jump down a level. Just looking at the hair gen submenu and the tab menu, you'll see that we have quite a large collection of nodes here that you can use to build hair related things or just other general effects and procedural modeling tasks. Let's start with the familiar hair gen actually. So hair generate is the equivalent of the object level operator. You'll see that the interface is essentially the same. This node is actually used internally by the object level tools. So the object level tool is essentially just a thin wrapper around this. You get all the power of it down here as well. And I can just plug in a skin mesh here, and that'll right away generate some curves for me. Let's just make them a bit longer. Now one thing that I'm missing is the nice shading that the object level tool set up. So for that we need to change some properties on the object as well as assign a shader. Just jump up, and you just want to go to the MISC tab here and enable shade open curves in viewport. So that gives me the nicer shading where it also respects the width attribute that hair gen creates. So on the attributes and appearance tab here, it's using that ramp to set up the per point width attribute. So I can modify my ramp here, and that'll show up in the viewport now, just like with the hair gen object. And of course I can assign a shader. So if I just grab a hair shader from the material palette, drag that on there, that works. Let's just make that black at the roots here and then red at the tips. And jump back. So another way I can work with this is I can use guide curves. That's the second input here. So the first two are for the static versions of the two. So static mesh, and then animated mesh, static guides and animated guides. Well, for this example, I'll just work with the static version. So let's make this a bit sparser, and we'll actually use this hair gen to create guides for us. Something like this. And then use another hair gen, plug that into the skin again, and then actually use the output of this, so the curves, as the guide curves for the second one. We'll make those a bit thicker as well. And quite a bit denser. Maybe a bit less. So now whatever I do to these sparser curves will have an effect on these. So one thing I can do, for example, is just use the guide initialize again. That needs a skin input, so the second input here will output the skin geometry. And then it also requires a VDB. Let's just check here, skin VDB. So I need a VDB from polygons from the skin. So there is a bit more work involved, of course. But you can use this to create more custom effects and just plug everything together exactly the way you want it. So let's just point those straight down. And I think I might need a bit of exterior band on this as well for some of these effects to work well. So I'll specify that in world space and just make that a 0.1, and I'll actually fill the interior in this case, maybe 0.2. It's just necessary for something like this effect where the curves actually stay quite far away from the surface. For that to work well, you need the exterior information of the VDB to work. And then, of course, all the generic tools like lift. That all works the same way. Set my lift value here. You can see it affecting the generated hair right away. Another example of a useful SOP is the guide collide with VDB. Let's plug that straight into here. You can use that in a similar way as the lift. Let's just lower these a bit more. And I think we need a slightly larger radius here. So you can use this to push hairs that might be penetrating the skin away from the skin. So you use the push amount and a range to push them out, and there's a soft fall off with the range here. I think these flickering hairs are actually, this is a bug in the viewport right now, it doesn't appear in the curves. Let's use a few more segments though. I'll go to 16. 16. So that works. And another thing you can do with a guide collide, you can plug in an external geometry. So let's grab something like, I don't know, the rubber toy again. I'll just fix those intersecting legs on it with a Boolean. Let's hide our external torus. Let's look inside here. So without the Boolean, I've got the intersecting legs. With the Boolean, that's gone. Just a union of all the pieces, all the disconnected pieces. And now I'll just transform that to intersect with my hair here. Let's just display the guides, then template this one. Just move it up here. Now I'll reduce my lift just so I have some intersections happening. Just point them straight out or down a little. And then you'll see when I plug my custom VDB into the fourth input here now. Oh, I don't have a VDB yet. Let's make that an actual VDB. And again, I'll use fill interior. And also set the exterior band 0.2, and then let's actually visualize this. I'll need a lower resolution as well. So now you see the effect of that happening. Let's visualize the polygon version of the rubber toy. And you'll see that I can get a nice soft fall off there just by adjusting these parameters. Probably pushing a bit too much, but let's adjust the range and then the push amount. I can also, if I just want that, I can disable skin collisions as well. So the skin is traveling through the third input and output here from up top. Let's disable skin and then adjust the push range to just work against the rubber toy. You can also use two separate ones, of course. Just do the skin collision first if necessary. So this can be used for all kinds of effects. You can use it for something as simple as this, or just as part of your guide grooming to make sure you don't have any intersections with cloth of the character or something like that. And it's even stable enough to use in animation directly. So you can have a moving character there, and it'll work quite well for that as well. Now let's look at another example. I'll take my rubber toy, just actually take that into a new object. Hide these. Let's do another hair gem with some length. And I'll just create a few hairs this time. Let's look at guide tangent space. So this is a fairly low level technical one, but basically the purpose is to give you a nice consistent vector space along the curve that you can apply certain operations in. For example, the frizz operator uses it to apply the noise consistently. So basically when this combination of character and hair now deforms or rotates, moves through the scene, let's just try that. Plug the animated version into the animated skin input here, and let's rotate that. And actually, let's change the template flag here to the transformed version. So rotate that. You'll see that the vectors stick to the character there. And the way that works is it grabs that initial direction from the skin UV gradient by default. You can also specify the direction at the root explicitly. And then it uses that to set the vector direction at the root of the curve, and then propagates that along the curve, minimizing twist around the axis of the curve itself. So that means when I do some operations here, like frizz, for example, that's a bit crazy, but it's actually a good example. Let's just increase the resolution here a bit, and then maybe set that to a lower frequency. So you'll see that the direction here stays quite consistent from point to point. It tries to minimize that twist around the curve, and that really helps when you have, for example, when you have a simulation going on that throws the hair around quite wildly. It's important to do this for things like curling, where you need a consistent space to work with. Now in this final segment, I want to look at some of the set of operators I want to highlight is the pack groom as well as the unpack groom. So again, just a SOP in here. And the purpose of this one is to package your groom and all the parts that make it up into a consistent format. So it takes as input the rest guides, the rest skin, the animated guides, and the animated skin. So in this case, let's consider these to be our static guides. So this is going to be our groom. So we just plug in the guides here and the skin. And then this will make that our animated version. I'll just add some quick keyframes here. Template that again. Let's just move that for a second. And then plug these guides into here and the skin. And now I can plug that, well, before I can plug that into here, I need to unpack it again. So that's an unpack groom. So that's basically the the opposite of this. And now I have a single wire here that contains everything. And the way that works is it just merges everything into a set of 4 packed primitives. If I jump over to the geometry spreadsheet here, you can see those named here, so you can see the individual parts. And of course, you can do all the typical operations with packed primitives. So if I just add a packed edit, I can change the viewport display to bounding box. So you'll see those are just 4 packed primitives now, not the individual curves. And I can write that to disk as one unit. So the advantage of that is you track everything as one entity, so you can't have like a diverging groom and a diverging set of simulated curves or something like that. Let's just write out, let's just check that my animation worked there. Let's just write out those 24 frames. Write that in the background. And so the unpacked version, I can plug that into the hair gen here. So I'll ignore everything coming from the top, because I now have a self-sufficient groom that contains everything that I need for the final hair generation. One kind of quirk here is I need to cross some of the wires so they don't just plug in straight. The reason for that is we decided to make the rest input the primary first input here, just because it makes sense to grow curves from the skin rather than just plugging the guides in first. But it just means that the skin, you get that from the second input here. So you have here it's guide first, then skin. So you just cross these 2 wires, and then the same for this. So if I hide the rubber toy there, you can see the result taking into account that animated version, and it's all coming from disk now. So if I jump around here, you'll see the result of that, the character moving through there. And that's exactly the way it works in our object level tools as well. Let's just jump back to those. I have a guide simulate here. So jumping inside, we have an unpacked room here. So when this is basically the guides coming in from that reference, from that groom object reference that we have on the object level. And when in that reference, between those objects, they actually travel as that packed unit as well. So we have an unpacked groom here that picks apart these objects, and then we simulate the guides and add some attributes to the skin, whatever is necessary, and then pack that again. And then the file cache is actually what you see exposed on the caching tab here. And then this is our output with that is used by later objects that may reference this one. And this is just used for individual references of the individual parts. So works exactly the same way, and you're free to use these operators at the sub level as well. That concludes this masterclass on hair and fur in Houdini 16, and I just want to thank you for your time and interest. While there's always more things to cover and greater detail to go into, I hope what I've presented here has been relevant and useful for you. Thank you.